Hello and welcome. We are Team ElecTron from Canada, participating in the Airbus 6 Challenge with our solution, OptUp. My name is Melba.
I'm Jennifer.
I'm Shahir.
And I'm Bruce.
For Airbus Challenge number 6, it is the Power of Earth Observation and AI, where we take UP42 satellite imagery data from Airbus, combine it with artificial intelligence for our own solution.
So we'll be applying this to urban planning, which is the development and design of land use considering many factors, to build infrastructure for things such as transportation, power distribution, as well as telecommunication. So this leads us to the ideal 15-minute city, where it is accessible to facilities and services such as grocery stores, education, and parks within 15-minute walk. It's shown to have economic advantages such as cost reduction in produce, as well as behavioral advantages such as community building and friendships. There are some issues we need to address, for example, carbon emission. So there's a significant amount of time and gas spent on daily commutes. By more efficient planning of routes, this allows us to access certain locations and promote zero-emission options such as walking or biking. Another issue that this can address would be industrial pollutant exposure by taking into consideration of proximity to residential areas as well as conservation areas.
Introducing our solution of OptUp, where you can do it all by customizing the AI with whatever factors you need, such as sustainability, emergency response, plan smarter, and build smarter, combining our technology with Airbus UP42 satellite imagery data.
Here's how OptUp makes the magic happen. Let's take the example of carbon emissions and how we can reduce them using public transportation. First off, if you want to improve public transportation, what better way than to reduce bus optimization times? There's 4 ways we can do this across the globe. We'll start off with data collection, taking the satellite imagery of all of the buses across the globe and seeing how long they take to get to their destination, as well as labeling where they might want to go. We'll then apply analytics to see how long it's taking for the buses to get to their locations and how efficiently they're transporting the people. We'll then take all that information and transport it into one data set, which allows us to use one machine learning model to train on that data set, which will then make an informed decision about how we can improve and add on to existing bus lanes and improve traffic times within cities across the globe. So let's go back to the basics. It all comes down to the data that you get. OptUp absolutely needs high resolution images that are taken from the Airbus satellite. This lets us track where buses are going, how long it's taking for it to reach its destination, and where similar points of interest might be around it, such as schools, hospitals, and touristic destinations. Of course, we're also taking into consideration future use of the bus, such as population growth, as well as potential events such as the Olympics that might come up. All of this is then converted into one data set. This is done by using a variety of analytical tools, one of which is UP42, which is a vehicle detection tool that allows us to track the traffic flow of buses as they traverse across the city. We will then relate this to travel time as well as the usage rates, and then combine them into a single data set, which will be talked about more by Bruce.
Moving onward in the pipeline, the first portion of our model will utilize labeled traffic data to train a convolutional neural network, which will produce labeled data from high-quality satellite images. We will then associate this data set with real-time traffic data to feed into our sequence-to-sequence model, which will create optimized bus routes with target destinations in mind.
Here's how OptUp does this better than any other competitor on the market. First off, we're working on a scale that no other competitor is currently doing. We're using satellite images. We're able to target any city across the globe, big or small. This allows us to scale up our operations exponentially, as well as customize towards any client we're working with. Of course, because our data is so vast, we need extremely efficient algorithms, so we're using state-of-the-line machine learning models to do so. This means our decision-making is very robust, and of course, everything is data-driven, meaning urban planners can be confident that they're making decisions that are well-informed. However, it's not just calculations behind the scenes. There is the human aspect, of course, so we're taking into consideration sustainability and how we can build better cities for the future beyond just numbers on screen.
Now introducing our business model canvas. Our value proposition is to improve life quality, as well as avoiding potential health risk in the proximity. Our key partners include the provider of our satellite images as well as cloud storage, and our key activities or services include technical development of the AI as well as validating our data sets. The key resources will include the physical showroom, computers, our staff, internet, and electricity. Our main method of communication with our customer would be online as well as with some in-person meetings. And our channels would be through networking, electronic mails, public speaking, as well as engineering as marketing. And Melda will be introducing the following points.
Moving on to our customer segments, we do have 4 of them. We have government at all levels, including the military. We have urban planning consultants, private sector urban developers, and the ultra-rich who do have their own cities. The current US market as of 2021 for urban planning software and services was valued at $144 billion USD. The revenue forecast for 2028 in 5 years is $192 billion. That gives us a 4.2% CAGR growth from 2021 to 2028. Our income model is based off of a consulting model. It is project-based or city-based. It is per person hourly rate times 3, added static and variable costs. An example in Canada is a company called Ecopia, which was awarded a $10 million Canadian contract to use its AI services to help with the deployment of high-speed internet. Operational costs, so data, it will cost about $1.2 million per city based on the size of the city to get the satellite imagery data that we need. Machine learning model over 5 years will cost about $95,000 to upkeep. Marketing and research are variable costs. Other costs are office space and showroom, payroll, and employee benefits for all of our staff. Here we have our competitors that we have mapped based on value and technological advancement. We have NearMap, which uses aerial photography from planes, MyoVision, which uses cameras put on traffic lights, Urbanetic, which is virtual planning software, European Space Imaging, and OptUp, which both use satellite imagery, but the biggest difference is that European Space Imaging uses AI to modify and look at cities' hotspots. OptUp will actually plan your city. For innovation, we are innovative in 4 different ways. We have our technology, which is using our deep neural network to solve complex calculations and apply it, which is sequence to sequence. We have our product is not only a product, it is also a service. So it combines both of them. It will look at your city and plan it. We have radical innovation in the sense that you can customize your AI with whatever you need. It can be immigration, climate change, or farming, or more. We have incremental innovation in the sense that a lot of these parts do exist separately, just not together.
So as discussed before, this product can be used in many different applications such as arable land, emergency response to natural disasters, refugee camp planning, and addressing change in demand depending on the local age distribution, and also taking in consideration of population density increase in specific urbanized areas, as well as building infrastructure such as transmission towers.
Thank you for listening. Merci beaucoup. Questions and comments are welcome.